So in the previous video, you learned how to express your final answer properly by considering the sig fig or decimal place. Here, let's try to do some simple examples and make sure you pay attention to that as well. So I want you to spend some time to work on question 11, question 12, 13, and also 20. So pause the video, do them first by yourself, and we'll go through it together.
A few moments later.
Because of the time, I already wrote the answers here. So the first question is about electron volt, which is something that you may not learn before. So in case you are interested, you can go to check out another video. I will put a link in the description below. You will get to learn it when you learn chapter 5 in IB. Okay, so for now, I think you can just take it as an equivalent, as in, so this amount of joules will be equal to 1 EV simply. So both of them are referring to energy. So it's just a very tiny bit of energy. For part A, is asking you, so if you have 2.5 EV, how many joules would that be in equivalent, of course. So what you have to do simply is you have 2.5 EV. Usually we don't write the units, but if you feel like to, it would be nice if you can write it down as well if you like to. So since it's quite obvious that 1 EV will be that much, so you just have to multiply the number 1.6 times 10 to the power of negative 19. In fact, what you can think of in this equivalent formula, you can actually consider it as 1 equal to 1.6 times 10 to the power of negative 19 joule per EV. Okay, so this is one way of thinking it. If you struggle with whether or not you need to multiply it or divide, because if you look at the unit here, it was EV because it was 2.5, and so what you do now is you still have the EV, but then you multiply this whole thing with 1, which is the same thing because you can multiply 1 as many as you like. So the actual unit for this one is actually joule per EV. So if you think about this, then these two EV will got cancel out, leaving you with the unit of joule. So that's how you can get the unit joule here, which that's why we'll have to multiply here. If you do division, then obviously it won't work. One thing you may need to pay attention is your answer has to be expressing in 4.0. So the 0.0 is important because if you press the calculator, 2.5 times 1.6, you get the exact value of 4. However, like what we learned in the previous videos, you still have to specify your significant figure correctly. So here, because both of these has two significant figures, so your answer should also express as 4.0. So you shouldn't be writing 4 only. For part B, is basically the other way around. So if you kind of making a guess, then you know for part A, if this is multiply, then part B is divide. So but in case you only see part B and you are not sure whether you need to do divide or multiply, let me give you a way so that you can do it in a very safe way. So once again, it's just by considering the units again. So 8.6, that one is in terms of joule, and again you want to convert that into EV. So the one that we have down below, once again 1.6 times 10 to the power of negative 19 is actually in the unit of joule per EV, because what you're doing is that you divide 1. Alright, so this value, yes, the value doesn't equal to 1, but then together with the unit, you can consider it as 1, alright, without any dimension. So if you think about the unit here, then joule and joule will cancel out, and then you will be having like EV negative 1 bracket negative 1. That means it is EV in terms of unit at the end. So from your calculator, you will be able to find the number of 5.375. And once again, by using what you learned in the previous video, because 8.6 is 2 sig fig, 1.6 is also 2 sig fig, so your answer can only be in 2 sig fig. So that's why you have to run it up to 5.4. Okay, so next question is about the volume expressed in cubic meters, but the size they give you is in cm. So anyway, so let's just put down volume equals to 2.8 cube or 2.8 cm bracket cube, And then what you want to do, since you want your final answer to be in meter cube, so you simply change it to meter first. So that is divide 100, and then just keep the cube outside. And maybe I think it's better if you can keep meter like this to be just more sensible and consistent. And so the last thing you have to do is just by calculator, and you would have a number as in 2.1952 times 10 to the power of -5, and then once again we have to consider it as sig fig, so 2 sig fig, then that will be 2.2 only, okay, in meter cube. Alright, so the next question is just the opposite. So it tells you that the volume is 588 millimeter cube, and asking you about the size in meter. So I guess first of all you just have to find the size first. Let's call it S. Then that will be cube root of this, but then that will be in millimeter, but then we can still do this part first. So the answer would then be 8.3777. I'll just take more digits. Apparently you only take 3 significant figures because of what you learned again in the previous video, but then I'll just write more here. So this should be in millimeter, and so I guess I will use not exact equal. So and then you have to change it to meter. So in that case you have to divide it by 1,000. So simply that will be 10 to the power of -3. And because you take 3 sig fig, so that would be 8.38. Okay, so that will simply be the answer. So this is the last question in this video, but then this is nothing really special. What you have to do is just to use the equation that they provide, which actually you should know already since you have probably learned mechanics, and you just have to plug in the numbers, and eventually with your calculator you can find the full length of your answer as 26.66718367 or something. Alright, almost. But then once again, by following the rules that you learn, you should notice that this only has 2 sig fig, right, which is the least amount in our raw data. So you can only express it with 2 sig fig. So that is to say it's going to be 27. So I'll express it as 2.7 times 10 to the power of 1 instead. And so the unit for power will be watts, so W here. And that's all for this video.